Hello. Let's start with a short recollection of what we have discussed so far. SDN is an extremely new thing, and like all new things, it has its share of elevated expectations. Naturally, vendors and startups want to jump on this bandwagon. More so, its definition is very fluid and flexible, making it fit almost any modern quote-unquote centralized control tech. Secondly, the OpenFlow protocol offers us a truly unique approach to network design by allowing you to plug your own shims to a lower level switch behavior. These two factors call for a split in the market. On the one side, we have big vendors trying to adapt their existing or coming to life products to comply with the SDN definition. On the other are genuine startups and open source products that are looking for problems to solve with this new approach. So let's take a look at the products out there and check if anything stands out. Easiest way to enumerate all the SDN products is SDN Central. While not completely up to date, and it's not impossible with this current pace of SDN evolution, it is the most complete online database of everything SDN related. Be advised though that they rent a lot of space to big vendors, and you may be subjected to some shameless marketing out here. So the incumbents first. Juniper has been always saying that their older tech, such as QFabric, is already an SDN. While I do agree, it became eventually apparent that it doesn't get any traction in the media. That's why Juniper has acquired a startup called Contrail Systems. Juniper Contrail, as it is known today, and barely a month ago open-sourced variant OpenContrail, are a hodgepodge of numerous technologies. Let me open that. It uses overlay tunnels to span layer 2, as well as BGP and XMPP to manage devices, and in general, it seems to be a well thought out product. There is a very, very good documentation available even in ebook format. So I advise you to try OpenContrail if you're looking for a production-ready, although not OpenFlow-based SDN solution. Next, Cisco. Well, Cisco had its own share of acquisitions and has been quite mysterious about the project they are working on, but in the end, it presented a Cisco application-centric infrastructure framework. Quite similar to the previous product, ACI is a cloud-centric network virtualization and layer 2 spanning tech. So overlay networks again. Unlike Juniper Contrail, it isn't open source, and it does not offer any interoperability with third-party devices, nor older Cisco switches. Finally, the well-known VMware NSX. Driving home the point that only network overlays got attention from big vendors, NSX is a cloud-centric overlay tunnel orchestration solution. All three are quite the same in their goals and directly compete with each other. What about smaller companies? Hmm. Arista concentrates on a tight integration with VMware, serving mostly hardware. Although it has a new protocol in works called Direct Flow, but honestly, I have yet to see what it is. Let's better recap Plexi. Plexi is a truly innovative startup that adopts DWDM to serve as a data center backbone. Maybe better try this one. Using tools like their data services engine to collect information about endpoints, what services do they run, which VMs need to talk to which other VMs, and at last OpenFlow. This product is able to provision DWDM light paths dynamically to respond to ever-changing requirements of the data center flows. I'm honestly very excited to see such a bold product out there. Although, well, it has to be seen how successful they will become. Here they advertise how their new product gives you an insight into a new era of compute and especially data centers. All right, big switch networks. There is not much to say. They were among the first to offer us a complete open flow based solution, Big Tab Fabric. And since then, they have contributed a lot to the SDN cause by open sourcing their libraries and tools. But besides of that, not really too much to say. At last, we have a bunch of white box switch vendors. IW Networks, Noviflow, and Pika8 among them. All of these companies work on offering you a bare bones, not feature rich, but open flow supporting switches. And they got some market share in the data centers, especially by giving you these quite cheap devices to replace full featured big vendor switches. Finally, the open source. On SDN Central, we have a separate directory for open source projects, but it isn't well maintained and organized. So I better do the old school wooing. We have a host of SDN controllers that were open sourced. Box, Beacon, Rue, Trima, and of course Open Daylight. They all differ in an approach or programming language or architecture, and there is no other way to choose than to try many. POX is a not very well documented, but easily hackable Python-based framework that provides you with an OpenFlow parser and event loop, basically allowing you to write a higher level Python application that will be able to talk to switches without ever bothering with low-level packet crafting or parsing. Trima does mostly the same, but using Ruby language. And it is probably the easiest framework to start writing your own application. Very clear and concise. But both Trima and Fox were in the first wave of SDN controllers and do not support support OpenFlow beyond version 1.0. Although there exists a Trima Edge framework in development that tries to fix this problem. All right, Ru is an extremely well-documented Python framework that is quite similar to POX in its design, but unlike POX, it got some real use, especially in Japan, and is probably the only non-Java SDN platform that is highly tested, robust, and production ready. Ru is the controller to learn if you want something easily hackable, and Java is not, but still production ready. There is also a very well documented resource here, and everything is very, again, clear to start writing your own application. And yes, Open Daylight. I have to admit that Open Daylight is unique in a way that it has huge support from all the big vendors. It has completely overshadowed the Beacon SDN controller, which is also open source and Java. But, well, I have to say that Open Daylight is still in its infancy and shouldn't be used anywhere except for the lab. More so, I do not consider Open Daylight to be a truly good platform for experimentation. It is too enterprise-ish. We can see here a very extensive architecture design here, and complex to be easily hackable by lone enthusiasts. There are also quite a few software switches out there. SnapSwitch, for example, integrates tightly with a small set of NICs to deliver the best performance, and OpenVSwitch is a de facto standard for many other virtualization products and the switch I recommend you to use in your SDN lab. While indeed OVS is a software app and inherently slow at that, its modular architecture allows it to have hardware acceleration drivers, the feature used by PK8 startup in their switches, for example, and also makes it highly adaptable and usable in many different environments such as OpenStack, VMware Cloud, or any other virtualization platform. And that's it. While our discourse was a very cursory one, I hope it provides a decent introduction to many different tools that, especially open source ones, you can start using in your lab today. Next episode will be a discussion of the core of our virtual SDN lab, that is OpenVSwitch. And thank you for your attention.